Hi, I'm Leah Kissner. I'm a principal engineer at Google, and I'm here to introduce this session, which is about practical privacy protection. And privacy is often construed to be about observance or disturbance by other people, but I think about the goals much more widely as respect, in the sense of due regards for the feelings, wishes, rights, or traditions of others. To build something great, or even to build something acceptable in the sense that people will actually accept it, respect for the people using it, the people who it affects, and the societies in which they live is key. And interestingly, when I see people interacting with a product or a system that doesn't have that respect, they'll call those failures privacy failures. So I wanted to take a really broad look at this field, and these panels are designed to kind of cover a lot of the different pieces that I think go into this. So I'd like to bring up our first speaker. So Elizabeth Zwicky works at Oath, and she's going to talk about the grim truth about how real people, real companies, and real governments use email. She's a distinguished engineer at Oath, which is Yahoo/AOL. And her team focuses on protecting people from bad email. She's one of the authors of RFC 7489, which is DMARC, and of O'Reilly's Building Internet Firewalls. And she's had a varied career from startups to big companies, including system administration, security, email, and teaching. So welcome.
Where's my clicker? So yes, my company is not actually named OAuth, but that's okay. I answer to OAuth. So why am I talking about email truth and illusion when we talk about privacy? Email is one of the oldest protocols that we still interact with all the time. It's a fundamental protocol that we do things with. It's showing its age in a lot of ways. We would like to increase its privacy in a lot of ways. And most of the people who set out to do this are pretty firmly on the illusion side of truth and illusion. So to start with, the number one illusion, the mailbox that you see is not the mail. Now, I work for a really big mail system. There are not very many really big mail systems, but almost all people using mail use one of them, or lots of them, maybe several. And our numbers are that about 80% of the attempts to send us mail, we reject. So about 40 billion, yes, I mean billion with a B, attempts come into our systems to send our users mail a day, and we reject 80% of them. And I, of course, don't exactly know these numbers for other email systems of our size, but I certainly know that when I give these kind of numbers, my colleagues at those mail systems nod understandingly. And I know that some of the big antivirus companies say things like 60% of all the mail on the internet is spam. And me and Google and Hotmail look at each other and go, like, did they get that number upside down? Because 60 is way too low. There's no way that 60% is the right number. So when you start thinking about mail solutions, they need to be not just about the mail you see, but also about that other big chunk of mail that never actually hits your mailbox. Okay, the next piece is, the hard part of what I do every day is not getting rid of bad mail because that's easy. We certainly have interfaces on which we're like, if you just turn all of it off, you only have a 1% false positive rate, and that sounds pretty good. No, the hard part is getting rid of the bad stuff while keeping the mail that people want. And why is that hard? Well, first of all, it's hard because engineers tend to think that there is good mail and there is spam, and if you were some kind of god, you could just sort them into the two piles and be done with it. That's not how it works. On one end, there is no mail so terrible that somebody on my mail system doesn't want it. There's mail so terrible I won't give it to them. But there's no mail they don't want. People buy pharmaceuticals on the internet from spam. That's why people keep sending it. Those people want that mail. People buy love on the internet a lot. At the other end, there's no mail so good that everybody wants it. I have seen people vote their own pizza receipts as spam. I don't know why. Maybe it wasn't a good pizza. In that giant middle, you may not have noticed this, but politics and religion are a little divisive. And the mail that one set of people wants about politics is the mail, or religion, is the mail that another set of people emphatically do not want to know exists. So, a lot of our time is devoted to getting it right, not at some overall level, but for individual users. There's an individual opinion, and some things are not spam, they are mail that this user doesn't want right now. The other fabulous tension for us, there are good people who make money sending email, but the primary people who make money sending email are spammers. Like, engineers ask me all the time, well, why would they bother? Because they get paid. It's very, very straightforward. You know who doesn't get paid for sending email? Your preschool, your parents' old age home, your utility company, your church, your sports team, basically everybody you want mail from. That's not how they make their money. So, the people you don't want mail from have a vast incentive to be really good at doing whatever you want. Whatever I want. If I said I was only going to put mail in the inbox if it contained the word aardvark, 100% of spam would have the word aardvark in it in like a week. And, you know, all the mail you wanted would not, because aardvarks are not that popular. So, here's the big deal. I can get people who I don't want to receive mail from to upgrade and be as privacy sensitive or as security sensitive as you like. Plus, who is at the absolute end of the long tail of implementation of a new standard? Hardware devices. People whose mail is sent for them by hardware clients. Now, statistically, most of those people are, in fact, security cameras with fans in front of them, but let's ignore them for the moment because I don't care much about their mail. And there are more of them than you could imagine. But who I do care about, I care about a lot, are, for instance, people using accessibility devices for the blind and other accessibility devices. I care about printers. Why would I hate cameras and love printers? Because if you are on the other side of the digital divide, right, and you don't have a lot of internet access, and you want to fax something or email yourself a document, what you do is you go to the local corner store, and they own one of those big fancy printers that most of us use on our employers, and it sends the mail for them. And it's got a mail client that's hard-coded in it, that's trying to send mail. And this is kind of an easy problem if it's in your company, it just sends mail as your company, but it's not an easy problem if it needs to send mail for your entire neighborhood. So at the very long tail, the people who are slowest to adopt, people with feature phones, so the developing world, are disproportionately underserved communities. They are disproportionately the people who it is morally most important to accept mail from. I personally have written code that exists for no purpose other than to correctly accept mail from specific accessibility devices for the blind. So, Okay, so the whole problem is harder than you think, and the mail you can see is not all the mail. Worse yet, your mail is not everybody's mail. Engineers like folders. My research labs team likes to say, you know, people talk about filers and pilers. And when it comes to email, really what we have is pilers and noise. Like, the only people who care about folders or filters are engineers. And for a while, I did not really believe them. And then at a point where our employees were 0.1%, less than that of our user base, I went and looked at all the folders we delivered mail to. 4 of the top 10 were named after internal products. Okay, really users, I mean, there are always users who love every feature, but they're more or less noise. Engineers never say there's too much spam in my spam folder. Users say this all the time. And here's the thing, Facebook and Yahoo, it was Yahoo at the time, collaborated on a thing called RRVS, Return Receipt Verified Since, I think, don't shoot me if I have the acronym wrong, which allows you to say, if you're a sender, my user verified this email address on such and such a date. If your recipient registered more recently than that, they're not my user, don't deliver the mail. Which is a fabulous way for people to avoid problems with reclaimed accounts. You had a speaker earlier who talked about what happens if you use an account to set something up and then you never use the account again. When we first turned this in, we discovered, to our horror, that actually users register Facebook accounts with email addresses that don't exist. And it's not like they're like, oh, here I am, I'm signing up for Facebook, I'll make something up, and then I'll go register it. No. They're like, here I am, I'm signing up for Facebook, I'll make something up, and then when I need to authenticate the account, in 9 months, I'll try to register the email address then. What bad thing could possibly happen? This is a noticeable percentage of email from involved in people who do this kind of thing. And it took most of our engineering team a long time to sort of scrape their jaws up off the floor. That had not occurred to us as a thing people do. Similarly, here's another one that's great. People often ask about all those advanced fee fraud, the people who say, I am ambassador so-and-so, and I have this large crate full of gold at your nearest airport. And they have names like Lawyer Smith and Ambassador so-and-so. And you're like, who would believe that? Turns out a lot of West African lawyers and ambassadors do this. And when I say ambassadors, I mean people sending mail to the US Department of State as Ambassador so-and-so. The reason that the fraudsters do this is that this is a perfectly reasonable cultural thing for them to do. It makes total sense. Now, the other thing I used to dislike accounts named Mr. So-and-so. Most of those are also West African. Until I discovered a new thing. Turns out it's kind of popular if you're sending out save the dates for your wedding to spin up a new email account. Why not? They're free. Named Mr. and Mrs. I'm going to pick on the Smiths forever because I have no sense of what to make up. Mr. and Mrs. Smith. Then they send mail to all their friends. Then my algorithm deactivates them and they hate me because they have just spun up a brand new account, sent mail to a lot of strangers. So all of these things are things we don't think of when we look at our mail, but they are things that make total sense in the context of other people's mail. Sorry.
So thanks, Elizabeth. And next up, we have Maritza Johnson, and she's from ICSI, and she'll be talking about, wait, how was I supposed to know baking privacy into the user experience.
Thank you. Oh, wait. Do I get to use my microphone?
Oh, sorry.
I assume this works. It sounds like it works. Hello, everybody. I am so excited to be here today. Back when I first heard that RSA was in the works, in that 12 hours it took for the event to sell out, I was like, oh my goodness, this is just such like a warm-hearted, feel-good moment that this was being planned. So I'm really excited to be here. When I was invited to be a speaker, I, of course, said yes immediately and had almost no idea what I was going to talk about. I figured I could pull it together. 10 minutes to talk about privacy. I literally talk about privacy in my sleep sometimes, so I figured I could do this. And then in the intermediate weeks, I feel like the privacy gods have kind of blessed me with headlines lately that really kind of touch on something that I've thought about for like the past 8 years, and that is, how do you design for people so that they understand the implications of the decisions they're making about their privacy? And how do you talk about their use of data, the use of their data, in a way that makes sense to them? So with the recent headlines about Cambridge Analytica, and I'm only going to talk about the incident by name right now, and then we'll talk about this abstractly in a way where we can all talk about solutions. So I feel like users kind of hear about a survey manipulating their data and kind of misusing their data, and they think, wait, what? Like, what the what? How was I supposed to know that this survey app, when I hit install, was going to take all my friends' data and my data and do something else? It just doesn't make sense. Then you also have product teams seeing this, and they're like, no, we designed that platform to do a different thing, and we didn't expect that the data would kind of come, get pulled out of the system and then be misused, and this is not what we intended. And people kind of feel generally kind of bad about this, and it's not a good feeling on either side, right? So the title of my talk is, wait, how was I supposed to know? And we could take it from both sides. We could take it from the user side, and we could also take it from the products team side. And from my perspective, I would say that my husband's been really excited that I've had to plan this talk, because anytime I start to kvetch about privacy and usability, he's like, be productive. You have to give a talk soon. So in the spirit of that, I'm going to focus on some advice for the people who are designing tools. I'm not going to say it's easy. I don't have hard and fast solutions for you that will definitely work. What I will say is that these are 3 things that you can try as somebody who designs technology, somebody who works on a product team, whether you're a designer, a UER, an engineer, a PM. And hopefully, these tools are something that you can use to do better. So the first thing that I would recommend to all of you, as somebody in a meeting where you're talking about the design of something that features somebody's data, guys, we are so far past PII as being the only type of data that's worth protecting and worth thinking about. If you're looking at data that is contributed by people, that's about people, like you should be thinking about certain things. And what I would recommend is to be humble, like we heard this morning. You are not your user. We have tools for getting to know our users, and I recommend that you start using them early and often in the design process. So this isn't just, I'm kind of taking a broad view of design. It's not just when you sit down to design the user interface. It's when you're thinking about how you design your system generally. So how do you get to know your users? One, like we talked about in the first panel, you could actually talk to your target demographic. Hopefully you guys have access to user researchers. If you don't, you can do research on the internet, on your own. We can call that desk research. Basically, go searching for information to find out what do we know about the people we're designing for, and what do we know about the type of data we're going to be using. If that's not available to you, if you feel like you don't have time, get in touch with a privacy expert. You can ask them, hey, what do we know about these users in this type of data? Or what do we generally know about things that are similar? There are lots of people who are active on Twitter who I think would be happy to give you some advice. There are organizations like the EFF, the ACLU, lots of people who are happy to kind of share that both inside your company and outside. A third group you might try, like we heard about this morning, would be extreme users. So I'm not suggesting that you design a product for every extreme user ever, but the more you get exposed to those special cases, the more you start to broaden your idea of what your product should do. So it can be very enlightening in how you might, consider those edge cases. I challenge you, when you're designing your product, to be brave and take a broad view of usability testing. I think it's kind of common knowledge now that we do usability testing to see if the user can complete a certain task in a certain amount of time with some level of satisfaction. When we're talking about privacy interfaces, I challenge you to take a broad view and start looking at stuff like comprehension. Do users understand the implications of the decisions that they're making? Do they understand the data that's involved in whatever feature it is that you're designing? As much as you can incorporate that into your testing and get feedback from real users, I think that can really help to inform what's working and what's not working. My final piece of advice for you. So if you've kind of checked out over the past few minutes and felt like those past 2 points really apply more to designers or user researchers or people designing kind of end-user products, I invite you to come back, because I think this advice can apply to everybody who sits around a table when you're talking about a product design. So when you're talking about something that involves user data, I invite you to be a leader and to push back against the status quo. When you're talking about collecting data, talk about, do you really need to collect that data? Can you, once you've collected it, reduce it in fidelity and store something else? Do you really need to store the data for as long as you possibly can? Or maybe can you have a reasonable retention policy? Can you add a new control so that people have more control? Can you store it in aggregate form? All sorts of tough questions that maybe kind of go against the culture internally, maybe go against a certain product idea. But I think these are the tough questions that you have to be asking when you're dealing with kind of data about people or people's data. And so I'd ask all of you to kind of be a leader in that way. I would also say, I often hear kind of in response to those sorts of questions, but wait, we want to preserve option value. So one thing that's interesting about privacy is that users kind of wrap privacy up in trust. And the way they think about companies using their data is very related to trust. So if you're building your products always preserving option value, think about how you build relationships in the real world. So if you're out there dating and you're trying to preserve option value, are you building a trusting relationship? So think about that when you're thinking about your users. Think about that when you're working on the data. Kind of treat data respectfully, ask these hard questions, and push your teams to do better. So I just want to summarize these 3 points for you guys. And then I'll also leave you with one question, or kind of something to think about. So if you kind of, in hearing this talk, wonder, where are the concrete examples? Where are the examples of product decisions where these things might apply? Wonder, why is it that it's not possible as a privacy community that we can talk about solutions in a way when we can all kind of test them? Like I said earlier, we don't have hard and fast solutions that we know work to solve many of our problems. So how can we build a community so that we can actually share the problems and work on solutions together? Much in the way that I think we've kind of achieved in the security community. So with that, I will leave these, and I look forward to taking your question or hearing the questions in Q&A.
Excellent talk. Okay, and the next up will be Nwokedi Idika. He's from Google. He's a software engineer, and his time is split between privacy reviews and engineering tools / infrastructure / features to support privacy. Prior to Google, he worked on security at Shape Security, MIT Lincoln Lab, and Purdue University. So welcome up.
Thank you, Leah. So at Google, I do a number of things, but one of the things that I do is work on this team called Elbow. And Elbow's mission is very simple. It's to protect the privacy of end users by nudging app developers towards privacy-safe development practices. Now, to understand how we achieve that mission, you kind of have to understand a little bit about our beliefs. And so when we talk about Elbow's belief, it starts off with this sort of fundamental truth that we think is obviously true, which is people are inherently good, right? And so then it follows that developers are good. And as a consequence, you end up with this situation. If there's a situation where a user's privacy is harmed by some app, it has to be inadvertent, right? Not on purpose. Now, you probably are thinking, like, surely you and Elbow are not that naive. And that's true, right? But we have the luxury of a world-class security team, a world-class anti-abuse team that focuses on the bad actors, right? We need to focus on the folks that are not actively being malicious, right? Because you could be a perfectly well-intended individual and still cause harm. And so we want to focus on those particular individuals because they also need a little bit of nudging. So you probably are subsequently thinking, okay, if I add it up, good users, and all they need is some awareness about what they're doing, then the problem is solved, right? Solution, end of story, we're done. But life can never be that easy, right? There's always some complexity buried in there, right? And that complexity comes from the following: procrastination. Procrastination is making it very difficult for us to attain our objective in terms of pushing developers towards where we want to go. But before we sort of dive into this, we need to level set a little bit about what procrastination is. And so I'm going to leverage the ideas of both Pierre Steele and Cornelius Koenig. So they came up with this equation, this procrastination equation, that is known in academic circles as temporal motivation theory, right? It's the combination of sort of expectancy theory and hyperbolic discounting. And it's a very simple equation. So motivation, right, that's the thing. That's how desirous are you in terms of achieving some goal or objective. And you have expectancy. So this equation really explains why you probably procrastinated on every essay in college, right? So expectancy, how confident are you going to kill this essay or do well in this essay, right? Probably not too high, right? Then you talk about value. Like, it's how confident are you or how much reward do you get out of the outcome? And then you say, okay, with impulsiveness, you have, how distractible are you, right? Like when you talk about an essay, pretty much everything else is more interesting than doing your essay, right? And then if you have the opportunity to go to, say, like a football game, basketball game, and your essay is due like a year out, talking about delay now, you probably say, well, I could probably just go to this game. But if the game is like today or tomorrow, rather, your deadline is the day after, you're probably thinking, maybe I can bring my laptop to the game, work on my essay there, and make it all happen, right? And so given the generality of this equation, given its applicability, it shouldn't be surprising that it has applicability to our use case, what we really care about, which is getting developers to do the types of things that we want to do from a privacy perspective. So the behavior we're interested in is this behavior around the transmission of hardware identifiers. So from a best practices standpoint, we think there's only a handful of cases, namely 2 cases, where using or accessing and transmitting a hardware identifier actually makes sense. And pretty much every other use case, there's a better alternative, right? And so what we want to do is minimize those cases where it isn't legitimate for you to be looking or accessing these hardware identifiers, because it allows you to track individuals across applications, and you as a user have no control over this, right? So we want to minimize that. So the first thing that we did, the first nudge, had to do with Android Studio. So if you're going to be developing an app, chances are you're going to be using Android Studio, and boom, how cool is it that as you are accessing one of these hardware identifiers, you get this warning, this lint warning, basically saying, hey, don't do this, it's not recommended. What you should be doing is using one of these other identifiers, and in the event that you happen to fall into one of these exceptions, it might be OK. So this is the first nudge that we did. And now the task is to say, OK, how does the procrastination equation think about this, right? So from an expectancy standpoint, how confident are you based on that warning message that you can execute? On a scale from 0 to 1, I would say somewhere in the middle. Why? Because, well, I still have to figure out whether or not these new identifiers have the same properties as this sort of the Bluetooth address that I was trying to access in that particular example. I have to determine whether or not this will affect my application in ways that will make sense. And so while I'm pretty confident that I can go look all this information up, I still have to go look that information up and figure out what the implications are. And then from a value standpoint, it's pretty low, right? Like in that warning just said, hey, it's not recommended to do this. You should do these other things. So, what reward am I getting out of this outcome other than saying, well, I got rid of this lint warning, right? So I would say the value here is pretty low. So you score that as a 0.1. And then from an impulsiveness standpoint, well, I don't know if you've ever used Android Studio, but it's very intelligent, but it's also very chatty. So it's telling you lots and lots of things, and why pay attention to this warning versus another? But depending on how healthy your application is, you may have fewer warnings, you may pay attention to it. So I slot this somewhere in the middle, 0.5. And then from a delay standpoint, it's pretty good, right? It's right there in the IDE as you're coding, so it doesn't get much better than that. But again, as I said previously, you still have to think about what the implications are for your application before you can actually integrate it, right? So that gives you overall motivation, essentially 1/3. So now let's look at the second nudge. So the second nudge has to do with this thing called the pre-launch report. So with the pre-launch report, you as a developer are basically saying, hey, before I can launch, I want to make sure that everything with my app is A-OK. Among the things that we look at are privacy properties, right? And so in this warning, the major difference between the warning in the Android Studio environment and here with this pre-launch report is that it's now saying, hey, look, you might be in violation of a Google Play policy, 1. And then 2, this may affect your visibility in the Play Store. And so by saying these two different things, we are, hopefully motivating this developer, right? Because as a developer, you probably care about installs, right? And if you care about installs, your visibility very much matters in the Play Store. So now let's look at this through the lens of the procrastination equation. So from an expectation standpoint, I don't think we've given the user, the developer, any more information to make them feel more confident about their ability to execute on this behavior of changing the identifiers. And from a value standpoint, I think we've provided a lot of motivation. In some sense, right, we're telling them that you may be in violation of a play policy. And then 2, we're also telling them that, hey, look, this may affect your visibility in the Play Store. So now you have some motivation because your installs might be affected. Then from an impulsiveness standpoint, there isn't very much impulsiveness because this whole process exists for you to examine what may or may not be wrong with your app, right? And then from a delay standpoint, it isn't as good as being in your integrated development environment. So I scored that as twice as bad as you had in the earlier nudge. So when you look at it, put it all together, you have a fairly high motivation, right? So now when you want to put these nudges side by side, you can see, well, we had a 4% reduction over a given time period for the first nudge. Reasonable, right? Respectable. But with the other one, we had a significantly larger reduction in the usage of these hardware identifiers in terms of them being transmitted. Now, you might be saying, like, you didn't need an equation to tell you that, right? Like, the potential threat of having, the Play team affect your app by removing you from the Play Store because you're in violation or affecting your visibility, like, clearly that would motivate someone, right? But what this equation gives you is a framework for thinking about this, right? When you're thinking about these interventions, what should you be changing? What parameters should you be tuning in order to produce this better behavior that you're looking for? And so the takeaway for me really is the following. Look, I get it. You probably don't have an IDE at your respective company. You probably don't own a Play Store to use, but you probably have a bunch of well-intended developers who are probably not engaging in the best privacy-respectful behaviors, and you probably have a multitude of interventions that you can try. So what I'm suggesting is that you try out this procrastination equation, use it as a filter over your interventions, and determine whether or not this is the best approach for you to get the behavior that you want. And with that, thank you for your time.
So nudging. It's a good technique, works really well. And then I want to welcome up our next speaker. Seny Kamara is at Brown University. He's a professor there. And before that, he was a researcher at Microsoft. He works in cryptography. That's what crypto means, by the way. And mostly on designing algorithms and protocols that preserve privacy. A lot of his work has been on designing practical systems that operate on end-to-end encrypted data. So, for example, databases and search engines. So please welcome Seny up to the stage.
Thank you. All right, so I'll be speaking today about a project that's joined with Tariq Moataz and Martin Jou. So since 2013, there have been 9 billion records that have been leaked as a result of data breaches. And what's interesting is that, well, beyond the fact that there's 9 billion, what is also interesting is that only 4% of those were encrypted. Okay, so as a cryptographer, the question that comes to mind to me is why so few, right? Why do we only have 4% of the records that were encrypted? So is it because we're incompetent, or is it because we're lazy, or is it because it costs too much, right? And the answer is probably, maybe some mix of multiple things. But there's an interesting quote by a Yahoo executive that was interviewed by the New York Times after the Yahoo leaks, and he was asked, why wasn't this data encrypted? And his answer was because it would have hurt Yahoo's ability to index and search message data. Okay, so again, as a cryptographer, this makes me think, well, or this may motivate the following question: is does encryption really kill search? Right? Is this really true? I mean, intuitively, you may think, yeah, it kind of does, right? That's the point of encryption. It's supposed to hide all information about the data. So once we encrypt, of course, we're going to lose search. But it turns out that cryptographers have been working on this exact problem for a very long time, right? So it's been about 17 years that we've been developing algorithms and protocols and different kinds of cryptographic algorithms to specifically allow us to search over encrypted data. And there are many different ways of doing this. I'm not going to go over the details here. But it's become a pretty mature field at this point. And we have different approaches that give us different trade-offs. So we can do it more or less efficiently, we can do it more or less securely, and we can sort of tweak all these different parameters. So let me make a sort of one point clear, right? I don't want to suggest that encryption is a silver bullet, okay? So encryption is not going to solve all of our problems. It's only one small tool, right, in a larger toolbox. And of course, when we're talking about data breaches could occur in many different ways, right? They could occur due to phishing, due to dictionary attacks, they could occur due to somebody stealing something. But, I guess the claim that I do want to make is that encryption will at least help us, okay, in some way. Okay, so we have this work, this research that's been maturing over 17 years on how to search on encrypted data. And one question is, well, okay, so this is very nice, there's a bunch of papers, but can this actually be deployed in the real world, right? Can this actually be used? And so this is a question that we were interested with Tariq and with Martin. And so we said, let's try it. Let's see if we can actually deploy our research. So we looked at the space of end-to-end encrypted applications, and actually we're doing pretty well now with end-to-end encryption, right? Sort of, at least in some settings. So for example, with messaging, we have a lot of really nice end-to-end encrypted apps like Signal and WhatsApp, Facebook Messenger. We have a lot of different options. And in video, we're starting to do well as well. We have FaceTime is end-to-end encrypted, and Skype got end-to-end encryption. So we're sort of doing okay here. But one thing that we didn't really, at the time when we started this, that we didn't find were any end-to-end encrypted apps for photos. And I looked up some statistics, and it's estimated that in 2017, there were 1.2 trillion photos that were taken. And 85% of those were taken from a smartphone, 4% from a tablet, and 10% from a digital camera. Okay, so we have a ton of pictures that are being taken on our devices. So one interesting thing about photos, and in particular photo collections, is one, that they're very, very large, right? If you're anything like me, you have a ton of pictures, you take a ton of pictures, and you have gigs and gigs and gigs of photos. And because they're being taken, or because 85% of these photos are being taken on a mobile or on a smartphone, right? That actually suggests that you may want to store your photos in the cloud. It's actually a reasonable thing to do, right? If you're like me, like you can't fit your entire photo collection on your phone, so you're going to want to store them in the cloud. The other reason why you may want to store your photos in the cloud is that they have high sentimental value, right? You have pictures of your kids, your family, your parents, your friends. You really don't want to lose these pictures, okay? So that's another motivation to put them in the cloud. Now, the downside of putting your photos in the cloud is that your photos may be very private, right? These are pictures of you and your friends, your family, private moments, right? So you may have some concerns about your privacy, okay? Another reason is because data breaches actually happen, right? Especially with respect to photos. In 2014, at work, I'm not going to shut up on his name, Majorzik hacked 30 Gmail and iCloud accounts and was able to get 500 private photos, very compromising photos, including photos of celebrities, right? This was all over the news. But even if you're not concerned about data breaches, maybe your job requires you to take and hold sensitive photos, right? Maybe you're a journalist or a photojournalist or a documentary maker. Maybe you're an activist, and you have pictures that are very sensitive, right, that document government abuse or police brutality, okay? Maybe you're a citizen journalist. In some parts of the world, the only journalists that are still there are, regular citizens with smartphones, okay? So in all these cases, the common theme is that you may want to protect your photos. So with this in mind, we decided to create an app. Just call it an end-to-end encrypted camera app, and that's what I'm going to describe next. It's called PicSec. So this is what it looks like, at least for now. And so the first screenshot is, this is the login screen, and then you have the screen to take the picture, and the third is your photo collection. And the app works in the following way. So as I mentioned, it's end-to-end encrypted. So there's a key that's generated on your device, and that never leaves your device. When you take a picture with the app, what's going to happen is the app actually uses machine learning to tag the picture. Okay, so it'll do object recognition. If I take a picture of this room, it'll probably say there's chairs and there's people. So your picture is going to be automatically tagged with those tags. And then it'll also tag the photo with your location. And then it will give you the option to enter your own tags as well. Okay. So now, once your image is taken and tagged, the image or the photo is going to be encrypted, again, with the key that's only stored on your device. And all these tags, all this metadata is going to be encrypted using encryption schemes that support search, okay? That supports search over encrypted data. And then everything is going to be sent to our servers, okay? Our servers in the cloud. So now the encrypted photos and all the encrypted tags are backed up on our servers. And of course, we don't have your key, okay? So we don't get to see the metadata or the pictures. Now let's fast forward, maybe a year or 2 years, and now you have a photo collection that holds, I don't know, that's 40 gigs, you have thousands of pictures, and you want to recover that one picture from summer 2007, right? From a picnic that you had with your family in 2007. So how are you going to get this picture back, right? If your whole photo collection is in the cloud, and if it's, 40 gigs in size, how do you get that one picture, right? Obviously, you don't want to download your entire photo collection and decrypt it on your phone for this one picture. And so this is where the search on encrypted data comes in, is that what our app will allow you to do is it allow you to search over your photo collection, right? But in the cloud. So you enter your keyword, summer 2007, and the app will sort of process this keyword, right? It'll encrypt it in some form, and then send that to our servers. Our servers are going to take this encrypted form of your query, and it'll take all this encrypted metadata, and it'll somehow figure out which encrypted pictures it needs to send back, okay? And it'll send back just those pictures that match the query. And of course, the whole point here is that we never get to see your pictures, we never get to see the metadata, and we never get to see your query, okay? It's all end-to-end encrypted, and the key is only on your device. So the app is available on the Google App Store. It's only available for Android for now. And if you want to get access, you can contact us on Twitter at PicSecApp. So something else I wanted to mention is that, so for this particular app, we use actually a relatively simple form of search on encrypted data. of encrypted search. We can actually do things that are much more sophisticated. Okay, we can do things like NoSQL databases, right? End-to-end encrypted NoSQL databases. We can do things like end-to-end encrypted graph databases. We can also do, and this is sort of the more complicated or the most complicated thing that we can handle, which are end-to-end encrypted relational databases as well. Okay, and so some of the things that we're trying to do is to figure out what other applications and services can we build on top of this. So if you have any idea, I'd love to hear from you. Yeah, and so this is the website if you want to check out the app, and if you want to get access to it, just contact us there. Thank you.
And now we're going to be on to our last talk before the panel. And I want to introduce Sundaram. She is at Snap. She's actually the first privacy engineer at Snap and built their privacy program from the ground up. Before that, she was at Google and Symantec. And so she's right now been working on designing Snap features with privacy in mind and does privacy engineering reviews for the majority of the Snap releases and all of their acquisitions. So welcome, Shah, to go talk about machine learning privacy.
Thank you. So hi, everyone. I'm Shah, and today I'm going to talk about machine learning and privacy, basically all the buzzwords that are happening right now. So I'm a privacy engineer at Snap and formerly at Google, so some of this work I've done at Google. Basically, what does being a privacy engineer mean? So I review any launches for privacy as well as security. Basically, I look at the infrastructure, the design, the data, the UX, any additional UI changes that were input, so that to make sure that this doesn't harm our users in any way. So typically how the life cycle or evolution of a privacy solution looks like is I find a problem, identify it, catch it in the reviews, write documents about it, educate our engineers, add guardrails and validation around it. And as I do this over time, I look for patterns that emerge from me doing this all over again. And then maybe if I see enough patterns, just go and implement and build an infrastructure that will completely eliminate this privacy problem from the get-go. So today, I want to talk to you about machine learning. And as I do privacy analysis of any machine learning system, what are the patterns that I see and what are the problems that I see? So just to take us through this, I'll give you a very basic toy example of machine learning, where typically you have a set of user data. This is about users, maybe about their demographic, and in this case, a sensitive attribute like their salary. And how a machine learning person would approach this problem is take this data, do a lot of feature extraction, model training, and try to look for all the patterns in the data so that you have a trained classifier. And eventually, you'll have an automated system in which you can ask this trained classifier a question of, let's say, how much to pay this new guy, Charlie, and it'll give out a response of estimation of maybe this much with this much probability. So when we talk about privacy in this particular space, the question we ask is, how can we provide a valuable service and protect the user's sensitive information? In this case, I've just highlighted Alice, but you also want to make sure that each individual data is protected and nobody gets to know about it, and it is not proliferated much. So why does this problem exasperate in a machine learning environment is because the process of feature extraction and model training is very, very manual. All of these data scientists or machine learning professionals need access to this sensitive data, and only then can they build these systems. And the problem worsens, especially when the data collectors are one team or one company, and the data processors or people who are building this model are someone else. And we have seen this go wrong so many times in our system. Basically, whenever we send out, these collectors send out this data to the processors, they typically say that they have anonymized this data and send it out. And we see that it is very easy to de-identify a particular user and re-identify them. Here I give an example how Group Insurance Commission did that and released anonymized data set, which Latanya Sweeney was able to de-identify and find a particular disease that the governor of Massachusetts was suffering from. So how do you prevent this from happening? So we have some very good literature in the privacy world that we could use and build infrastructure to completely eliminate all of these problems from the get-go. So basically, you could use differential privacy, which will add some kind of a noise in the input as well as the output, and which will give you good utility, at the same time protect the user's privacy. You could use ideas from homomorphic encryption, in which you could encrypt the data and do analysis over the encrypted data. There are some limitations to it, but you could do a lot more still. The third thing is federated learning that at Snap we are heavily invested in, is you do all the analysis in the client itself. So all the model building is done on the client, and you send only updates to the server. So that sensitive data never leaves the client. And also there are ideas from secure multi-party computation where many of these teams could collaborate and generate the output, but at the same time keep the input sensitive to themselves. And we heard Seny also talk about a few techniques about crypto here. But these classical methods of privacy, so this protects against the classical methods of privacy. But as I do more reviews, I see a lot of problems for the users in these machine learning systems. And until, let's say, artificial intelligence takes over humanity, I think these are the important problems that we should look at, and that's what I want to talk to you about. The first thing that I see is misclassification risk to a user. Basically, could a false positive or false negative harm a user? So this is typically how this affects how the model is trained and what output a model gives. For example, any model that you train with machine learning, it's always going to give you an output that is an estimation of outcome. Basically, it is all probability theory. So probability theory does not say that this outcome will not happen. It says that this outcome will happen, but it will be very rare. So what it means is, let's say you have a machine learning system that gives you a best result with 99% accuracy. That's super high. But let's say it gives you an accuracy of 99%. What it means that if you see 100 events, one of them is going to go wrong for sure. So basically, what is going to happen is always one image is going to be mistagged or mislabeled. If you're doing label classification, one image is going to be mistagged or mislabeled. And think about a system like all of these big data providers or these big image classifiers, which contains a lot of user data and photos app. They are classifying thousands and thousands and millions of user photos, and it is very easy, or it is very likely, that one of them is going to mislabel it. And we have seen examples where the mislabels have been very, very bad for the user. The worst is in case of, let's say, automated cars, right? Think about a car that is standing at an intersection and that is trying to see whether the light is red or green. And if you say that the precision of the system is 99%, what that means is 1 out of 100 cars is going to run the light. So the account, or in this case, the user risk is very, very high. So what I suggest that instead of measuring the quality of the model with just precision and confidence, you need to anticipate the risk to the user for this low probability and low confidence events and put safeguards in place for the worst outcome. And have safe defaults. I think that's the only thing that's going to save us. The second point that I want to talk to you about is fairness. Basically, how can we design a system that can protect a user from biases? And this, I see, typically affects the data that we collect. Let's say you have the best machine learning engineers here, and you give them this data set about salaries for men and women, and they build you the most precise, exact machine learning model. But whenever you're going to question or ask this classifier a question, how much to pay a woman, it is almost always going to undercut a woman. And it is global. So basically, however you test this model, wherever you test this model, it is always every time going to undercut the pay for a woman. So these biases are very much inherent in the data itself. You could tell me right now that why not just get rid of the gender column and retrain your classifiers? Maybe in this example it works, but do you think in my example it is devoid of any race or ethnicity bias? It isn't, because there is a lot of correlation between your location, that is your zip code, and your race and ethnicity. So figuring out, there is no obvious method to figure out or adjust historical data to get rid of these biases. And it is hard to identify these different biases throughout our systems. And there are many anti-discriminatory laws that could help guide us and tell us what you should be careful about. But the data itself has so much of this context around it that the cultural context especially, that the machine learning model just does not capture. And corrective measures that we want to put in place that will probably alter these results are very much contentious legally and politically. I think Elizabeth talked about how sorting out male itself is tough. And so we are embarking on this kind of new research area where we don't even know what are the right measures to put in place. So if I have to characterize this in my evolution of ML solutions, I'm here right now. There are a lot of patterns of these happening, and we see that as we go towards these automated systems, we are going to have these big falls from those. So in the end, I would like to leave you with this checklist of any ML system analysis. Basically, first, we have to ask what training data is used and kind of what efforts are put in place to improve the quality of the data. So if you have any ML engineers, they will also ask you about these two things, and they will put a lot of effort in kind of regularization, bias versus variance, improving precision. All of those things are good for privacy. And so you should let them do it and give them all data, kind of good data as well as bad data, to make sure that they test their systems well. But at the same time, don't stop there. There are many more questions that you need to ask from the system so that you can get a very unbiased and a good model train. So basically, the other questions you need to ask are: how sensitive is this model's accuracy to changes in test data? What is the risk to the user if things actually get mislabeled or misclassified? And what are the scenarios in which this model can be applied? And lastly, is this model valid? As time changes, things change, and when should we retrain this particular model? So I think that's all. And so, thank you.
So we're going to move on to the moderated discussion portion of our session. And joining us as moderator is Allison Miller. So she is currently SVP Engineering at Bank of America, and she has spent over 15 years at the forefront of consumer identity, authentication, anti-fraud, security, and privacy at some of the world's leading online consumer-facing platforms such as Google, Electronic Arts, PayPal, eBay, Skype, and Visa. She has also pioneered the use of algorithmic approaches like machine learning to security problems, and has launched technology that protects billions of devices, accounts, dollars, messages, transactions, and ultimately people. So welcome up, Allison.
Come on up, everybody. Hey guys, it's the last session. How are you all doing in the audience? And then, what? Okay. Thank you. I'm a bit of a wooer, so I feel like not being in the audience, I want to encourage each of you to take that on. And hello to folks on our live stream. I'm very excited to be here. Thank you guys so much for your presentations. It's really interesting to hear sort of different angles on this problem set. Security conferences aren't usually where we get to discuss issues of privacy, but it's kind of the end game for consumers in that security and privacy are kind of always intertwined. And one of the things that I really love about discussions of privacy lately is that it used to be that the only folks who were really talking about privacy were lawyers. You remember when privacy professionals were all attorneys, and it was all about compliance, and the conversations were all about opt-out versus opt-in. But now we're actually approaching these as kind of design problems, or we're talking about them like engineering problems. So how has that changed the way that you approach the work at all? Have you been exploring that? I mean, you're a privacy engineer. How many folks here are privacy engineers? Okay, a few. I see a few hands. The lights are really bright. How many of you want to be privacy engineers? Okay, well, everybody's hiring. Everybody's hiring for folks who are interested in working on privacy engineering. How has the approach changed for you?
Definitely. Now we have a role called privacy engineer. Typically, it was just a security engineer. Now we have a definition of what a privacy engineer looks like. And we see that lawyers, yes, definitely help us with a lot of kind of inputs about what's the right thing to do. But when you get into the weeds of things and when the devil is in the detail, it typically needs an engineer to go and say what is good, what is right, what kind of encryption works where, what it doesn't work, or what it aids or it doesn't. And so definitely I see that being a privacy engineer, it helps in kind of product development phase itself. And even more than that, especially at the design phase. So more I get involved in the design, the better systems that we get in the end that protect the user.
Sure. So at Google, one of the things that I do is work with product teams to try to help them create more respectful products. And part of what you do, I mean, so if you're compliance, you just kind of say you are compliant or you're not compliant. But as a member of a privacy working group, part of what you do is help the team come up with a solution. And so you usually need to have a technical background in order to help them figure out how to best utilize these complex systems so that they can achieve a goal that is still respectful of the users and meeting their business objectives.
I wish that we would take it a step further, though. I look forward to see where the field goes as more technical people kind of take up privacy with a solutions-oriented mindset. So I guess I've been lucky in that I've always worked in privacy for as long as I've kind of been in the field. But like I kind of started on a team at Facebook where I worked with almost all lawyers. And, you know, we come from two different kind of approaches in how you approach the problem. And so your tool set is different. The way you think about problems and solutions is different. And so I see a lot of value. You know, my bias is I'm trained as a computer scientist, so of course I see a lot of value in computer science for finding solutions. But I really look forward to privacy going much more in the way that security has gone, kind of like in the way I wrapped up my talk to say, I wish there were more space for technologists to share in the common problems that we have in dealing with user data and thinking about how to protect data and collect data, and kind of have more of like a community discussion about best practices and lessons learned. I have a feeling that right now we're kind of long on lessons learned and maybe short on solutions. And I think having kind of like a safe space where we can actually talk about that as a community and talk about that as you know, tech companies would be beneficial.
One of the trends that I think is kind of interesting too is that with a lot of the dynamics of social platforms, it used to be, you know, like I'm Selena Kyle on Twitter. That's my pseudonym. That was back then, that was my attempt to get privacy, was to not necessarily be myself on a platform because I didn't know how I was going to use it or what the interactions were going to be like. So now we're crafting products where it's a social platform. So the difference between what needs to be shared or what we want to share versus what we want to keep secret, it's different for different folks. Like some people actually want the Canadian pharmaceutical promotional email, and other people consider it spam. We're creating this sort of dynamic, very complex matrix of options for folks in order to provide them choice, but yet they're not necessarily trained to navigate all of these options. So how do we provide them with simplicity so that we get to that ideal of the default is they're safe, the default is they're doing the thing that is sort of the one that will protect them the most, but yet also give them all of these choices. As a product manager, how do you think about that? Or a researcher?
Yeah. So one of you want to take it? I can.
I'll say something really short. That's a hard question.
Yeah.
Right? And I think you have tons and tons of people who are looking at it really closely and trying to come up with a way that, ultimately, it kind of ends up being a compromise in some sense, because trying to satisfy everybody with limited resources usually doesn't work out. But I think that every case is unique and it has its own nuance, and so it's very difficult to give a monolithic answer to that question.
Fair. Why don't I take a Elizabeth?
We have made some attempts to build email experiences that give people some more control over that, because one of the problems with email is that you tend to want to have a single identifier, but then you give that to a lot of people, and then it's right. But there again, you hit a big tension between users who want features, but it becomes difficult. So you can. There are places where you can make effectively a disposable email address. That's what we call them internally, as disposable email addresses. But you have to be really clued in to do that, to know to do that, to think to do that. And the classic example is, when do you give out your email address? You give out your email address when you're in line, you've been shopping, there's a screaming child, there's a cashier who's like, if you give me your email address, we'll give you 20% off. And you're like, look, I'm just so done with this experience. If I give you, don't even give me the 20% off, just shut up, right? Here's my email address. Let's be done with this transaction and get me out of here. And so that makes it very hard for people to negotiate multiple identifiers. And that's a tension I don't really know what to do about.
Yeah, sorry for asking a really hard open-ended question like that. Your work with the Google Play folks is really interesting, though, because you're not just trying to train users in dealing with all of this optionality and or issues. You're trying to train developers. So one of the things I was wondering is, how are they responding? Are the developers interested in this? Do they see this? The developers are basically good. I think I saw you write that. Are they interested in developing these controls, or are they pushing back on the feedback they're getting from your team?
So we haven't collected enough justifications or responses from those end users, or rather developers, in order to conclusively say what it is that they're doing. But from what we've observed is there has been a very positive response, where they would go a mile further than where we have thought they would go in terms of what they do. So we have some other work where we are encouraging developers to not use as many permissions, right? Like sometimes there's an abundance of permissions. They're collecting a whole lot of them. Maybe you don't need some of them. And what we found is these developers, in many cases, will, in addition to removing the one that we identify as like, hey, you probably don't need this permission, they'll go and remove some other permissions that we didn't tell them about. And so, for the developers that are receptive, they're very receptive, at least from what we've seen. But anecdotally, we haven't done a comprehensive analysis yet, but from what we've seen, it's been very positive.
Cool. Well, that's good security work too, right? If you don't need it, don't collect it. If you don't need the service, turn it off. So awesome. And that's kind of interesting too. I'm wondering if in your work, you as on the privacy side of the fence, do you find yourself clashing with your security brethren, or are you all often aligned? And obviously, everyone is working towards the same end goal, but are the methods meshing, or is there creative tension? between security and privacy in your world?
We get along like a one big happy family.
Oh, one big happy family. Awesome.
I think sometimes I see a tension not within those two teams, but more on the product team side, where they're like, well, why do I need to talk to a privacy person? I already talked to a security person. Or where sometimes it can feel right now like we have more actionable advice to give on security, and so that can sometimes be what gets tended to. So I can, and it's not really a tension, but it's kind of an interesting thing that shows up between the two.
Yeah.
But then, like, between the teams themselves, I feel like security folks are usually our best advocates.
Yeah, no, absolutely. They're the advocates. When there is tension, it's usually tension in terms of different threat models. And so you just need to like explain what your threat model is. Like, oh, okay, I get it. You know, you guys are using this threat model versus that threat model. Now we're all on the same page. But I think that generally there isn't really any friction between the two teams.
Cool. Hey, Seny, from where you sit as a researcher, you talked about some of the problems that you're looking at, research you're doing. What are the sort of other interesting topics that you think that maybe you want to bring to the folks who are building these platforms and see if what their ideas would be, or what other researchers are working on this space that are really pushing things forward?
Yeah, I think there's a lot of interesting developments in research. I mean, so my particular area is cryptography. And, you know, I think we've seen some really interesting things happen in industry. So, for example, I mean, obviously, Signal, WhatsApp, you know, WhatsApp deploying end-to-end encryption to, like, you know, I don't know how many people at this point. And, you know, Apple deploying differential privacy, Google deploying differential privacy. I think these were really, really sort of big events in terms of privacy. And there are a lot of other technologies that I think could potentially find uses. So what I work on is, you know, algorithms that operate on encrypted data. So things like, you know, databases and like information retrieval, search engines. But there's other things like one thing that was mentioned was secure multi-party computation. So this allows different people who don't trust each other and that may have data sets, and they need to compute some joint function on these data sets. But because they don't trust each other, they can't just share the data with each other. But they can still do this in a private way, in a privacy-preserving way. And so you can imagine training machine learning models using this, doing all kinds of analytics on data. And so that's, I think, another really interesting technology. There's been a lot of advances in making it more practical. Of course, one of the challenges with all this is that when we make these advances in research and we sort of make them more and more efficient, right? It's very kind of siloed, and it doesn't mean that because we have efficient algorithms and protocols that we can actually just, you know, drop them off into a product, right? There has to be a lot of work in terms of like usability, in terms of how do you build a real system on top of it, does it scale? So there's like a huge amount of like work that has to be done to do this. But I think with the examples of end-to-end messaging and differential privacy, we can see that it's actually possible to do. So I think that's very exciting, and I hope that there'll be more of these sort of tech transfers, basically.
Great. And the others, are there any technologies that you find especially promising that you're excited about when it comes to your ability to help protect users and their privacy?
Federated learning is one thing that I'm really excited about.
Federated learning?
Yeah, or any kind of doing as much analysis as the client can possible. And so not sending sensitive data, in the client I mean at the user's device or at the user's end itself, and not sending the sensitive data, if possible, back to the cloud or back to the servers that collect them. And if there is a lot of promise as these devices get more and more powerful, we can do a lot of privacy-preserving personalization, especially for a particular user in their own environment. And so that solves a lot of problem for the user where there is no way where that data gets out and gets leaked somewhere else. And that personalization is also always very user-specific, and two users don't share any of these learnings from each other in a very non-privacy manner.
So the idea there, just to repeat that, so essentially the client keeps the data. Yeah. They don't share back their data. It stays with them on their device, so their money stays in their wallet. They don't. Okay. Got it. Cool. That's cool technology. In security, we haven't always had as much luck pushing things down to the client side, but it would be very useful if we can
Yeah, the devices are
leverage
getting so
encryption and do
powerful
that.
right now, right? Earlier, they weren't that powerful, but now it can do a lot more. And so it's becoming easier. These technologies are more available right now.
Awesome. Any other new technologies folks are eyeing?
Maybe on my wish list would be a nice oracle that could predict what privacy concerns actually matter to people. So maybe somebody could start working on that. I feel like the past couple of weeks in the headlines, it's just been really interesting to see kind of an example of something that really has kind of like roused an interest in the use of personal data in a way that I haven't seen happen before. And I feel like actually maybe it did happen when we had like the Snowden revelations. I feel like a lot of security folks were like, wow, this was like my worst tinfoil hat nightmare come true. So kind of similar with like this, with the Cambridge Analytica stuff, it's kind of like, okay, so it turns out trying to tinker with democracy and undermine it is the thing that gets people riled up. But if we had an oracle that could tell us for, personalized suggestions that could help folks kind of motivate them to make changes to how they share data, that could be interesting.
Yes, I think magic oracles would definitely be interesting. I'm sure there's a few places where we could use those. But so I think that it's a truism, and it's going to be true on every technology and every platform, that different users have different needs, they have different requirements. What about some of the patterns that privacy patterns or design patterns that we learn from one place, can we translate them elsewhere? So for example, some of the things that you're learning from email, are those things that we can take to mobile messaging, to social? Maybe you can plug DMARC right now.
I could plug. I feel kind of bad about plugging DMARC on the previous question, because in my universe, which is kind of specialized, it's almost old technology now. But it does take a very long time to move whole internets places. And DMARC is a nice example of a technological solution that makes the world behave a little more like users expect it to behave.
How so?
When you look at the from address on a piece of email, you tend to believe that that means something. And in sort of non-DMARC mail systems, there's really no guarantee that means anything whatsoever. And what DMARC does is allow cooperating senders and receivers to ensure that the right-hand side of the @ sign actually means something, which, as the distance between like how people think email works and how it really ought to work is like here, and we've bridged a very small piece of that gap. We still don't know any other way than trusting the mail sender to have reliable, large-scale faith in the username side, but now the domain name might actually be true, right?
Okay. I think it's a neat, like it's a little bit of an elegant design, right? In that what it does is it puts more onus on the senders to play, and then it reduces some of the work or cognitive load on a user side trying to decipher these things, and it lets sort of the servers talk to each other, and it's a nice design efficiency.
The more or less new piece of it is actually that it allows senders to find out whether or not their mail actually authenticates. And it turns out that's useful for two reasons. One, big companies send mail in ways you might not expect. Big companies send mail in ways I might not expect. So most companies don't sort of send all their mail from one place. They send it from dozens and dozens of places, and there isn't like a master list where somebody actually knows about all of it. And that's a very big barrier for them in achieving authenticated mail. And when we were originally working on DMARC, that was the main barrier that we were looking at. But it turns out that the DMARC reporting, which is there mostly to get you over that hump, to get you to the point where you believe that if you turn this knob, you're not going to break something really important to you, also provides a more important piece of information in that reliably you talk to somebody and they're like, nobody would ever fake my mail. And you're like, that's just not true. There is nobody so, government agencies say, nobody would ever fake my mail. And I'm like, that's not true.
Right,
right?
I think it's tax season, we know.
The IRS is very clued into that, but not everybody is. And so these reports also give them a way to suddenly say, wait, why are people receiving mail from China claiming to be my agricultural products business in the middle of Iowa? Like, why would that be a thing? To which the answer is, I don't know, but it's not good, and you would probably be happier if they stopped. So it's a big driver for adoption, actually, that people are suddenly able to see these violations that were not visible to them before.
And making that transparent, making it visible, it helps a lot. An ounce of prevention being worth a pound of cure, if you will.
Yeah.
So folks who are running platforms, when all of the participants in your ecosystem are kind of on one platform, do you think that that gives you a better shot at setting up the right incentives so that folks or providing the right transparency to the senders and receivers, say, of content?
I feel like it's a good opportunity to do better. I think kind of pulling back a thing that you brought up earlier, what I would like to see would be more work put into finding the right default settings. Finding those right defaults that are for most users most of the time, and then also ones where if they're wrong for people, it's not a big deal, right? You want to try to find those like fail-safe settings for the defaults if possible. Where then if there's something that would expose a lot of your data, then leave that for the power users to discover. Leave that for the people who are really interested in kind of sharing broadly and widely to discover. Maybe don't make it the default, even if that would, delay the viralness of what you're working on.
Awesome. So privacy design or privacy engineering, figuring out what the right trade-offs are, making those kinds of pitches and those kinds of calls, it requires a certain kind of mindset and a skill set. So what do you all think makes a great privacy engineer or a privacy product manager or someone who's going to build these right tools and do the research that's needed?
Try to be the user.
Think like a user, okay.
I think that's what helps. And things like a user who's going to be very diverse from all the different backgrounds and how they plan to use. Maybe a teenage girl, or maybe someone in a remote place, or the old lady example that we heard so much today. So there are so many of these diverse examples of users that we can learn from and develop the product and look at the product from that perspective.
What about technical skills? Development, machine learning, encryption, the original crypto?
Maybe I'd say so taking it from a slightly different perspective, since I'm not in the industry, but I am in academia, and so I do teach. And so I think one thing is that maybe sort of at the undergrad level, one thing that we haven't done as well, I think in computer science at least, is educating our students to sort of have a broader view beyond computer science. So educating them in ethics, making sure that they have sort of a broader liberal arts education, that they understand more than just, coding. I know some schools are doing this now. We're doing this at Brown. I teach a really large undergrad class in algorithms and data structures, and I make sure that they get at least, some content about not only just machine learning, but about the ethics of machine learning and discrimination and all the things that we've seen in the past. But I think that's really important, that sort of the next generation of computer scientists, of engineers, of program managers, sort of have a more well-rounded education that includes, not just
not just
coding.
STEM,
not just STEM,
but other stuff.
Yeah, exactly.
So that you can think like other types of people.
Yes.
Love it.
Yeah, I definitely agree. I feel like taking the broad view on a lot of these issues just really helps to have a more well-rounded conversation around what the implications might be. It makes room to have a conversation about what the implications might be, where I think it can be kind of easier to not think about it, right? It's easy to think about your product existing and within a little bubble and not have to think about all the ugly things that could happen. So I think the more diverse perspectives you bring in, the more you're kind of having these conversations, the easier it gets.
And where typically, so you're doing research, inculcating young minds. Thank you. If you're engaged, but you also developed a product, so don't think we didn't notice that.
Well, it's actually free right now. It's not even a product. It's just
Well,
so. Well, yeah, that's true.
if a product is free,
Well, yeah.
Seny really doesn't want to be a product
like
developer right
I'm
now.
there's another moment there. I'm just sort of curious as to where you typically engage. So you're at Google, you're at Snap, wherever you are you engaging with the product managers to help them understand as they're designing the products how to threat model and how to think like all of these different users who might have different accessibility issues? Where are you engaging?
So I engage with both product managers as well as engineers. And coming from an engineering background, I think I understand engineers better and their code better other than other things around it. So typically, I find that going back to that point about education, if you talk to these engineers and explain them what are the threat models that you're worried about and what are the things that you have to put in place, I see that proliferate. I see that these engineers go and educate other engineers and talk about these threat models to put in place already in their code. And so if they catch some kind of a vulnerability, they come and tell these engineers, go and talk to Shah, because might be you're not supposed to do that, and she can tell you. So education is also a very big component here.
That's very similar to security. It's like,
Yeah.
yes, there will be a checkpoint at the end, but if you can pull it back and engage earlier and empower developers and designers to think about these problems and attack them earlier, then we end up with better outcomes.
Definitely. I feel like I just talk privacy all the time. So kind of like I joked that I talk privacy in my sleep. When I was working both at Facebook and at Google, I kind of just talk privacy all the time. So anybody who wanted to talk about it, it's like, find the privacy people. Mm-hmm. And I mean, it feels kind of lame to say that that's kind of a solution in this space, but it's how it gets started. And I feel like it very easily becomes more of a conversation that lots of people are having when they have the vocabulary to talk about it, when they have familiarity with incidents, when they start to see where things went wrong. Then all of a sudden you have, a small network effect of people asking similar questions, and it matters, right? Like just like for security, when you get to a situation within a company where you have teams coming to you asking for security advice, same thing with privacy. When you have teams proactively seeking your advice, you feel like you've made a difference. Because then you're not kind of trying to like walk around and listen to what people are talking about to kind of inject your privacy advice. Not that I would do that.
Not that you would do that. Awesome. Okay. Well, we have about a minute left, and I'm going to ask another hard question, but it'd be super fast. So just spit out the first thing that comes to your mind, PR approved, of course, which is, so let's fast forward a year. You come back to Ursa. What is a problem that you hope to solve, a feature you hope to launch, a group that you hope to connect with to make sure their users are their requirements are being met by your product or your research? You come back in a year. So you're not solving everything, but maybe there's a bite-size, a year-long type of problem that maybe you could solve. Anyone got anything?
For me, at least, solve the fairness and the bias issue in machine learning right now.
Fairness and bias in machine learning. Solved in a year.
Yeah.
All right.
Yeah. I want to see a big tech company be able to talk about their privacy failures in a way that we can then all think about solutions.
Ooh, I like that.
Boom.
Research?
I want to see more end-to-end encryption. That's what I want to see.
Cool.
More and more.
Developers doing threat modeling with privacy in mind, something like that?
Not really, but
Come on, you have 10 seconds.
I think I'll do one. Open threat modeling. Like, it would be cool if we sort of were trying to Open threat modeling. I'm not even going to explain it. I'm just going to throw that out there. Open source threat models for key populations, considerations and requirements. Elizabeth, you got anything? Something email related?
Man, in a year, I can. The problem is the things I can do in a year are really inside baseball. They're not amusing.
So you've got something, but it's hashtag secret.
It's not even secret. It's just so dull.
Because you're working on infrastructure, right? That's where the good stuff happens. Infrastructure.
Yeah.
You got anything to round it out, or we're going to call it?
I mean, like, there's definitely things that we're working on, but, you obviously can't talk about those things. So I'm trying to imagine things outside of the set of things that I know will be coming, in a year.
That's okay.
So
More hashtag secret from the privacy panel. I like it. Okay, thank you guys so much. Really appreciated the chance to speak with you and to listen to your ideas and the things you're working on. Everybody?
So much.